The next step is to create the transition between the handle and the revolved base. Creating transitions like this can be accomplished in many different ways. The method I'll be using involves splitting the faces to be merged and then bridging between them. I'll begin by splitting the face of the revolved boss. On the same plane as the sweep profile was sketched on, I'll create a new sketch and another ellipse. I'll add a vertical relation between the center of the ellipse and the upper control point. This keeps the ellipse from rotating. The ellipse will be 1.2 inches wide and 1.3 inches tall. I'll add a vertical relation from the center of the ellipse to the origin. This will keep the ellipse centered about the handle. To control the vertical position, I'll add a dimension from the origin to the center point of 1.1 inches. Using the split line feature found at Insert, Curve, Split Line, I'll select the cylindrical face of the revolved feature. Since the sketch is inside the cylinder, it can split the face on both sides of the sketch plane. It's best to limit this feature to a single direction to keep the model cleaner and avoid creating extra geometry. You may need to adjust the reverse direction toggle as well. The next step is to prepare the handle sweep for the transition. I'll open another new sketch on the front plane and draw a vertical line a short distance along the handle. I'll add a dimension of 3.1 inches from the origin. I'll then use this line to create another split line feature, splitting the face of the handle. Now I'm set to create the transition. Again, there are several ways this can be done. I'll demonstrate two ways, one using a solid feature and a second using a surface feature. As a solid, this feature must be done using a loft. Loft is the only solid feature that can do a blend like this. In this case, the loft is between the two split line edges. The tangency, or in this case, curvature settings, refer to the faces to one side of the edge. I'll change the tangent length for the start constraint to 2. This has the same effect as using the handle arrows on splines. A two-profile loft can be thought of as being analogous to a two-point spline. Curvature can be added to either one by using tangency constraints at the ends. Unfortunately, although the preview looks good, there are several start and end constraint settings for which the loft fails. In the end, I could not get curvature constraint to work at all for this part, only tangency. This would give unacceptable results for a part like this, so instead I'll move on to a surface technique.